Good morning. We're going to finish up your tissues, shoot, apical, meristem, and primary growth notes today. We talked a little bit about the tissues last week. And if you recall, we talked about simple tissues versus complex tissues. The simple tissues are made up of just one type of cell, where the complex tissues are going to be made up of more than one type. And then your complex tissues are going to be the three complex tissues in your plant are going to be your primary xylem, primary phloem, and epidermis. So if you recall, I told you that your primary phloem and primary xylem are going to make up what's called your vascular tissues. So these are going to be then made from what's called your shoot, apical, meristem. When we talk about a shoot in a plant, we're talking about the topmost part of your stem. If you look at the diagrams that I've drawn you, this is my very beautiful drawing of a headless or flowerless plant or something. So, but it's that region right at the very, very top of your plant. Now, that doesn't include, let's say there was a flower sprouting off the top. It wouldn't be out of the flower, it would be at the topmost part right underneath. There should be an area of growth, which isn't necessarily the flower. So, and this region is called the shoot, apical, meristem. Okay, with your shoot, apical, meristem, this is where your primary stem growth occurs from. So this is your shoot, apical, meristem is going to be made up of cells that are constantly dividing, undergoing cell division to make more cells. So the main job of your meristem is to do the following, which is to produce leaves, to produce axillary or lateral buds. If you look at the side here, or at the diagram, I've drawn you kind of those lateral buds. They're small little growth appendages, if you will, off of your stem that are from that might shoot branches. It's also responsible for making new stem tissue, so basically to make the, and because of that, it's the fourth reason, it's responsible for increasing your plant's height, which is called the primary growth. Okay, so now your shoot, apical, meristem, if you were to look at it under the microscope, it would be in what's known as a tunica corpus arrangement, and I've drawn that for you on your diagrams. It's just kind of this dome-shaped structure. You've got a few layers of cells, about 2 or 3 layers of cells, and that makes up the tunica portion. And then you've got your corpus, which would be underneath it. Those would obviously be your newer cells. So, but that's kind of what that shoot, apical, meristem is going to look like underneath your microscope. All right. If you're go ahead and look at the sequential pictures underneath that. So here's your tunica corpus arrangement in that first left dome shape. Eventually, what happens is you progress through these 3 or 4 diagrams as growth starts to occur. And eventually you get that little indent there in pictures 2 and 3. What eventually ends up forming is you get these, what I would call appendage growths almost, which are buds, lateral buds that are forming. And your shoot apical meristem is there in the middle. So those lateral buds would potentially become branches. Your leaf is the bigger, floppy appendage there. This is like the strangest thing. You wouldn't think looking at a stem that it's this complex, but it actually is. So that last doodle in the sequential diagram is I've drawn where the stem portion is. Your shoot apical meristem is at the is in the middle dome there, and it's at the top. And then you've got your lateral buds coming out, which would develop into branches, and your leaves developing off of that. So obviously leaves could develop off of your lateral buds once they progress into branches as well. So, okay, so this next crazy drawing underneath is going to kind of coincide with this next slide here that's up. So this is this bottom drawing here on the front side is a more it's a larger view of your stem. It's like it's taken a step back or two so you can see more. So your shoot apical meristem there is at the very top. This is your shoot apical meristem is responsible for making what are known as your primary meristems. There are 3 of them. Your protoderm, your procambium, and your ground meristem. Don't know why there's an N there. Those are your 3 primary meristems. Okay. From there, which remember those because you'll see these again in your root anatomy here in a couple of days. I think it's maybe tomorrow. No, a couple of days. It's on Wednesday. Because we're gonna have the protoderm, procambium, and ground meristem in your root also. These primary meristems then make your primary tissues, which we've kind of already talked about some of them. We've talked about your epidermis, your primary phloem, and your secondary phloem. What we haven't talked about are the cortex, pith, and pith rays. Okay, so you can kind of think of your shoot apical meristem. It's making all of those cells. It's kind of like they are the stem cells because they're going to make these other stem cells, which will make other cells. So, but it all comes from the shoot apical meristem. Okay, what your protoderm, that particular primary meristem will make the primary tissue, your epidermis, that outer covering of the tissues of these of your plant, of your stem in this case. Your procambium is your other meristem, primary meristem, and it's going to make your vascular tissue, your primary xylem and your primary phloem. Remember, those are complex, just like your epidermis. Those are complex tissues made up of several different things. Your ground meristem is your, like I said, your last primary meristem, and it's going to make up your cortex, pith, and pith rays. And we haven't really talked about those yet. So, and I did talk about this earlier, but all of that primary stem growth is going to occur from your shoot apical meristem. Okay, so if you look at your diagram, I will explain this now. Okay, so this is what I would call a side view of your stem. You can see that your shoot apical meristem is there at the top. You've got some leaves, a couple of leaves coming out, and then you've also got those lateral buds there. I didn't draw it on every single leaf, but I drew it on 2 of them. But you can see on the outside and on the sides of the stem I've drawn the epidermis. This, remember, your epidermis is a primary tissue. So in parentheses, I've labeled this as your protoderm because that's your primary meristem. So your epidermis there makes the outside covering of your stem and leaves. Then there is a, I'm going to skip. You see the little squiggly squiggle helical lines there on the outside edges of your stem. I've labeled those. Those are your, that's going to be your xylem. I don't know how well you can see it because I drew it out of order and then realized I needed to stick it in there. But your xylem is on the inside. There's a thin line there in between the xylem and your epidermis. That would be your phloem. So those two tissues, remember, are your procambium. Procambium is the primary meristem. The primary tissues being xylem and phloem. It's on the other side. And then there is a space in between, and I labeled it at the bottom right. The space in between your primary phloem and your epidermis is made up of this tissue called the cortex, which comes from your ground meristem. Your ground meristem will make this cortex tissue, which is located between your phloem and your epidermis. Your pith and your pith rays, we'll talk more about the pith rays here in just a moment, but your pith is basically this center part of your stem that's in between the xylem on the left and the xylem on the right. Remember, this is coming from your ground meristem, which is that primary meristem. And I've shown you where the newer cells are and where the older cells are. Should make sense because the newer cells are going to be closer to that shoot apical meristem. Okay? As they get further down, they become a little more elongated in your epidermis. So that also helps with the height. So, okay, so if you go ahead and flip your page over, I've taken a cross section of your stem. So now we're not really talking necessarily about the shoot apical meristem. We're basically getting another view of how all of the tissues are oriented in your stem. Okay, so just so you know, this is kind of a generalized. It's going to look a little different depending on if you are a monocot or if you are a dicot. So this is a very generalized doodle, just so you know. But basically, you've got the epidermis going around the outside. You can see that. This is where the guard cells would be. I didn't draw them in this particular diagram. We'll talk about it tomorrow when we go into the primary stem anatomy. But so you've got your epidermis there. The cortex, remember, is that tissue that's found between your phloem and your epidermis. So that's just that outer edge of cells there. It looks like I did not label it, so sorry about that. I kind of had a brain fart. on my diagram, but I'll go ahead and add that to yours. Because on my diagram I only labeled the primary xylem. Forgot about the primary phloem. So primary phloem is going to be on the outside of those vascular bundles, those little seed-like structures. Your primary xylem will be on the inside, and that should make sense if you flip back to the other side and see that your phloem is on the outside and your xylem is towards the inside. It doesn't show it that it's in those bundles, but that's actually how they're oriented. So that's how your water, your sugar is going to be able to move throughout your plant and up the stem. And then your pith is that inner area. Again, that should make sense from the side view that we've drawn on the front side. It's just all that center stuff. Now the pith rays, this is what we haven't talked about yet. Your pith rays are going to be the tissue that's located in between the vascular bundles. So we weren't able to draw that on the front side because it was not three-dimensional in that sense. So, but we can draw it this way when we take the cross section. So the pith rays are the cells that are connecting your pith to your cortex. So that's basically how your stem is set up. Like I said, it's going to change a little bit depending on whether you're a monocot or a dicot with a vascular tissue. We'll talk about vascular versus non-vascular here in a couple of days, but just know that this is all with vascular plants. This won't occur with non-vascular plants. They don't have xylem and phloem and all of this extra tissue. So, okay, the last thing that we're going to talk about today are some additional elements in your xylem, your primary xylem, in regards to your secondary cell wall thickenings. So, if you remember, you've got primary cell wall, secondary cell wall. Primary is on the outside, secondary is on the inside. Secondary is usually thicker. Okay, so there's some additional wall thickenings that can occur specifically with tracheids and vessel elements. So this is going to be added from this additional thickening is going to occur from the inside of your vessel elements, and your tracheids is not going to occur from the outside. So I've drawn you, I believe it's 6 on the top there, 6 different versions of your vessel element. So, okay, so with that, the first one where it's just a plain vessel element, no additional cell wall thickening, doesn't really work. There's not a lot of support. It needs the additional kind of thickening there to help it with its structure. So it's developed some of these different 4 different versions. You can have your annular, which is reinforced circles just throughout the vessel element. You can have helical spiral, which is just like it says, it's just a helix or a spiral going through, providing some additional support there. You can have what's called scleriform, so it's kind of a zigzag pattern there. The next one, my professor drew. It doesn't have a name because it doesn't work. But it's where there's a reason why all of the cell walls don't thicken all at once throughout the inside of the vessel element, and that's because since it's so thick like that, there would be no way to get water to the cells on the outside. So you can put a lot of cell thickening, not necessarily a pattern, but you've got to leave pit fields. And so that's what that last one on the far right is, the sixth example, and that would be a pitted vessel element. So, and remember, these vessel elements are going to be making up your xylem. Okay, so it's very important that water gets through, since that's the primary way, the primary job of your xylem is to transport water. So obviously you need, that's why it's bad that the cells on the outside don't get the water there. So that's your pitted one. So water can go through those pit fields. Sorry, so those are bordered pits, meaning they've got that extra secondary cell wall kind of overlapping, so the openings of the pit fields aren't very wide. Okay, so the last two drawings that are on your diagrams there are the ends of your vessel elements. So here are your vessel elements that you can find inside your xylem. And then specifically, these last two doodles are talking about the ends of your vessel elements, because if you recall, your vessel elements are left open, like toilet paper rolls. There's two versions, though, actually, because one of them truly is completely open. The other one has what I'll call striations or lines kind of going there. So the completely open-ended vessel element is going to have what we call a simple perforation plate. So there's no extra tissue; it's just completely open. So, and this occurs in more complex plants. On your second one, the scleriform perforation plate, it has it's got some tissue still kind of striated across there. So basically what's happened is the enzymes haven't completely dissolved the ends of the walls. So, and this actually obviously would slow down the flow of water. So that's why the simple perforation plate is found in more complex plants, because the enzymes have completely dissolved all of the wall end, whereas with the scleriform perforation plate, the enzymes haven't, so it's going to be in more primitive plants. So, so this kind of wraps up your primary growth, shoot apical meristem, and types of tissues. I know it was a lot, so if you do have any questions, do please ask. I'd be happy to try to clarify anything that you may have questions over. And tomorrow we'll look more at the stem anatomy. We'll talk a little bit about the differences between monocots and dicots, and then kind of go into the differences between a monocot stem and a dicot stem. So hope you have a good Monday. I won't be here tomorrow, but my sub will have your diagrams, and I'll try to load your lectures so that way you guys can just get going and watch those tomorrow without me. So hope you have a good Monday.